Good morning, friends. Now we'll see some more problems on how to formulate the LPP for the given data. So now the problem will be like this. A manufacturer produces two types of models, M1 and M2. Each model of the type M1 requires 4 hours of grinding and 2 hours of polishing. In the sense, if we want to produce one piece of model M1, so it has to be processed 4 hours on grinding machine and 2 hours on polishing machine, whereas one piece of model M2 requires the work of 2 hours on grinding machine and 5 hours on polishing machine. The manufacturer has now two grinding machines and three polishing machines. Each grinder will work for 60 hours a week, and each polisher works for 50 hours a week. So, by selling one piece of the model M1, the manufacturer is getting a profit of 4 rupees, and by selling one piece of M2, he is getting the profit of 5 rupees. So, now the problem should be formulated such that the manufacturer, how he has to allocate his production capacity to these two types of models M1 and M2, so that he will make the maximum profit in a week. So formulate it as a linear programming problem. Now the solution will go like this. The decision variables here will be my x1 and x2, which are the number of units produced of model M1 and model M2. Therefore, x1 and x2 are the decision variables. Now the objective function. Since the profit is made on both the models, and we have to maximize the profit using these two models M1 and M2. So the objective function is maximizing Z. That is equal to, okay, by selling one piece of M1, so the profit obtained is given here 4 rupees, and one piece of M2 will fetch the profit of 5 rupees. So if I am producing x1 number of pieces of model M1. So the profit obtained will be 4 into x1. So if x1 value is 1, so the profit obtained is 4 rupees. If x1 number of units are produced of model M1, so the profit obtained will be 4 into x1. Similarly, by selling one piece of model M2, so the profit obtained is 5 rupees. So by producing x2 number of units of model M2, the profit obtained will be 5 times x2. So the objective function is maximum of z is equal to 4x1 plus 5x2. So now the constraints. So the constraints is are the number of working hours of grinding and polishing machine. Now number of hours available for grinding. So it is said that totally 60 hours a week grinder is available, and a polisher is available for 50 hours a week. So here my objective function is, so okay, so number of uh, working hours available for grinding. So that is so totally manufacturer has two grinders. So for each grinder, number of hours available is 60 hours. So for two grinders, it is 60 into 2. So that is 120 hours. So now the model M1 requires 4 hours of grinding, and model M2 requires 2 hours of grinding. Hence the grinding constraint is given as, okay, for it is one piece of M1, 4 hours are utilized on grinding machine for x1 number of units. So total grinding hours is 4x1. Similarly, one piece of model M2 requires 2 hours of grinding. If I am producing x2 number of units of M2, so total grinding hours on model M2 will be, so it is 2 into x2. So model 1 grinding hour requirement plus model 2 grinding hour requirement together should not exceed 120 hours. So it is less than or equal to 120 hours. Similarly on polishers, so we have uh, uh, three polishers, and here it is said that so it is 50 hours a week on each polisher. So total number of polishing hours available is now 50 into 3, so that is 150. So that is 150 here. So totally we have here 150 hours. So model 1, one piece requires 2 hours of polishing. So for x1 number of units, it is 2 into x1. Similarly, one piece of M2 requires here 5 hours of polishing. For x2 number of units, so it is 5 into x2. So M1 model M1 polishing hours plus model M2 polishing hours should not exceed here 150 hours. So that is less than or equal to 150. So non-negative restriction is that the number of units produced, either it will be 0 or greater than 0. It cannot be having minus values. So x1 comma x2 greater than or equal to 0. Finally, the LPP is formulated like this. So maximizing z is equal to this 4x1 plus 5x2, that is the objective function, and the constraints of a grinding machine and polishing machine which stated earlier will be written here, and the non-negative restrictions x1 comma x2 greater than or equal to 0. Thank you.